Good morning, everybody.
Good morning. Hope everyone's doing well. Might just see if anyone can hear us. If you can just double check in the chat, we'll just make sure that everything's working okay before we lift off.
Good morning, Hagip. Morning, Harry. Morning, Sarah. Rachel.
It's looking good. Angela says we're a bit broken. Hopefully that improves.
Hopefully.
Seems most people can hear. Just make sure that we're nice and loud for everybody. I think we'll probably wait just 1 or 2 minutes for everyone to join. We've still got a few people joining into the demo now, but we'll probably get started as soon. Hope everyone is doing well, regardless of whether you're in lockdown or whether you've just been freed from lockdown in the case of some of our South Australian attendees. So I hope everyone's keeping safe and yeah. Hi, Martin. Hi, Jude. All right, I think we're a couple of minutes past now, so we might kick off and any of the latecomers can join on in. What do you reckon, Jim?
Yeah, maybe 1 or 2 more minutes.
All right, we'll do a 60-second countdown.
60 seconds.
This is your last chance to join the webinar, everybody. And also just like to thank anyone as well that's from New South Wales. I know that the press conference is on right now, so you've made a good choice. This is going to be far more enjoyable than whatever's on that press conference this morning. Yeah, I think we're probably good.
Yeah, I think we're good too.
I think we might kick off, everybody, if that's all right. So strap in. So my name's Jack, and with me today we've got Jim. We're both civil engineers here at the Concrete Masonry Association of Australia. And today we're just going to go through a little bit on pavement systems, concrete segmental pavement systems, specifically how they relate to water-sensitive urban design. So just going to quickly go through a little bit about us at the CMAA and who we are and what we do here. So we're the peak body representing concrete masonry manufacturers of Australia. So this is going to include your concrete bricks, blocks, pavers, and designing and construction of retaining walls. So you can see on this slide a little bit of what we might do here. We have manuals and we sit on Australian standards and code boards. We conduct research with numerous universities around the country to facilitate improvement in design and construction within the concrete masonry sphere. And obviously, we advocate for positive change within the industry. So our strategic vision here at the CMAA is to make it easier to build in block and pavers. We have sort of a three-pronged approach to do this. So we want to develop talent in the industry. So this is obviously through educating our engineers and designers. We want to facilitate important conversations within the industry. So we want to, again, as I mentioned, promote positive collaboration within different spheres and, promote healthy conversation within the industry. And lastly, obviously, we represent our members. So we like to promote our members' products as well and make sure that they're used in the correct and proper manner. Just got Milka say she can't hear us. I think everyone else can. So hopefully Milka, you might just want to check your audio as well.
Yeah, maybe rejoin. Maybe that'll fix it.
So yeah, just quickly, a few of our members, just to sort of jog everybody's memories. I'm sure everybody here has heard of at least one of these bad boys. We've got Adbri Masonry, Austral Masonry, as our two larger sponsoring members, as well as our state members, so brickmakers in Western Australia, as well as Boral, National Masonry, and a few of our smaller general members and associates as well. So these are the companies and the members that we represent with regards to the Concrete Masonry Association. And our key strategies, again, to sort of deliver our strategy of making it easier to build in block and pavers. The first one that you may be familiar with is we have our annual Think Brick Awards. And this is to promote engagement with architects. So this is to celebrate design and construction from an architectural sphere within concrete blocks, bricks, and pavers. And I see Jim's just posted a little poll in there. So yeah, I'd like to see, if this is your first time attending a webinar, let us know. And on top of this, we obviously have engagement with engineers, which includes our webinars like this one here today. But furthering on top of this, we also like to promote our members through roadshows and technical committees. And we have even our Golden Trowel Awards, which celebrates excellence among brick and block laying apprentices. So as you can see, we're involved in numerous activities here at the CMAA to promote positive change and positive advancement within the concrete masonry area. And again, what can you get out of the Concrete Masonry Association and what can we provide you with? Well, we obviously have a number of free resources and as well as a technical hotline. So we're a not-for-profit industry association. So our job and what we want to do is help you use our members' products in the best way possible, whether that be from a design, a construction, or a maintenance sphere. So don't hesitate to get in touch with us by email or by phone, or even today in the chat as well. Feel free to ask questions. This is your opportunity to, reach out to us and, promote a little bit of knowledge sharing between your council or your company and our association here. And we have a quick little video that I'd like to show off, or that we'd like to show off here, that sort of summarizes what we do here at the CMAA and what we're here to sort of service you with. So I'll just see if I can bring that up.
And projects your council
and I might also
with regards to concrete masonry.
Just to see.
We also offer our Approved Installer program, which provides training for engineers and paver installers in segmental pavements. Whether they're in-house or subcontractors, the Approved Installer program can help avoid product failure, optimize construction methodologies, and minimize maintenance issues for all matters related to concrete blocks and pavers. Concrete Masonry Association of Australia is an industry association representing concrete masonry manufacturers. Our mission is to make it easier to build with concrete blocks and pavers, which is why we offer all of our services and resources on a complimentary basis to councils. These include our technical services, industry-recognised pavement design software, technical resources, industry networking, technical committees, and our training courses. Our engineers frequently work with masonry products and offer their technical design services to help you effectively manage your projects. We offer industry-leading software tools such as DesignPave and Permeable, which assist engineers and landscape architects in pavement design, alongside live webinars and in-person workshops where we demonstrate how to use the software. We have a range of technical manuals and fact sheets easily accessible from our website to guide your engineers when working with concrete masonry. We facilitate opportunities for you to get in touch with our network of industry members whenever you need to sample their products or receive technical guidance. Another valuable resource is CMAA's Technical Committee, which is comprised of experienced industry practitioners who can discuss any issue in the industry and projects your council is interested in with regards to concrete masonry. We also offer our Approved Installer program, which provides training for engineers and paver installers in segmental pavements. Whether they're in-house or subcontractors, the Approved Installer program can help avoid product failure, optimize construction methodologies, and minimize maintenance issues for all matters related to concrete blocks and pavers. Your trusted source of information is the Concrete Masonry Association of Australia. Our mission is to inform, educate, and provide guidance along the way for councils on a consistent basis. Give us a call today and keep thinking pavers.
in conclusion, I hope everyone enjoyed the video, but I think it sums up what we're about and what you can get out of the Concrete Masonry Association. So again, feel free to ask questions, anything you want to know, we're here to help you out. So today we're going to go through a little bit about what water-sensitive urban design is in Australia and how we might achieve this. Then we're going to touch a little bit on permeable concrete interlocking pavers, as well as some of their benefits and their applications. Then Jim's going to run through some policies and market development and how this might apply, particularly if you're working in a local government sphere. And then lastly, we're going to touch on some further opportunities, not only for permeable pavements, but also for your concrete segmental pavements in general. And this is going to flow into future episodes of our webinar series as well. So I might palm off to Jim, and he might take you through a little bit about water-sensitive urban design in Australia.
Yeah, thanks, Jack. So to start off this webinar, let's firstly look at what exactly is water-sensitive urban design. We all know that governments, whether it's your local, state, or federal government, they tend to be big on sustainability, not just environmental sustainability, but also social and economic sustainability. And this is essentially what water-sensitive urban design is all about. It's about sustainably managing your water resources and sustainably managing your water infrastructure. I'm just going to read out a quick definition from given by the South Australian government on what is water-sensitive urban design. South Australia is actually one of the leading states when it comes to water-sensitive urban design, so they really know what they're talking about. But they define water-sensitive urban design as a well-recognized approach to managing water in urban environments in a way that minimizes the negative impacts of urbanization and maximizes economic, social, and environmental benefits, right? It has the potential to deliver more livable cities by providing green spaces, by assisting the management of floods, by reducing urban temperatures, maintaining home gardens, property values, reducing the flow of pollutants to our natural environment, and also minimizing the need for expensive infrastructure upgrades. So a lot of benefits come from water-sensitive urban design. One of the big reasons why we need water-sensitive urban design is population growth. Currently, we have a population that is larger than ever recorded and will continue to grow in the coming years and decades, right? And this is going to be a big problem in the 21st century. Whether we can have enough resources and whether we can provide enough resources to everybody living here. And this is not unique to water. This also applies to food, to energy. But for today, obviously, we'll only talk about water. Just throwing some quick facts your way. 90% of Australians actually live in urban areas in Australia, and 80% of population growth will actually occur in Australia's 5 biggest cities: Sydney, Melbourne, Brisbane, Perth, and Adelaide. When we think about how we have these densely populated urban centers, the issue not only becomes whether we can provide enough water for all these people, but also whether we have the infrastructure that can help us adequately and sustainably deliver large amounts of water to people living in densely packed places, right? So that's a big issue. Another issue that comes with urbanization and us living in urban areas is the stormwater generation that is created from impermeable surfaces. So to give you an idea of what I'm talking about, when we're out in the countryside, when a big storm comes through and it rains, a lot of that rainfall volume, a lot of that water gets absorbed by the ground. 95% of it gets absorbed by the ground. When we're in a town or when we're in a city where there's a lot of infrastructure, where you have a lot of roads, where you have a lot of buildings with roofs, all these surfaces that prevent water from entering the earth ultimately generates stormwater runoff, right? All this runoff is going to be directed to a drain somewhere down the road. When you have all this water directed into a small pipe, you're going to have two options. Number one, you're going to have to spend either a lot of money making a lot of drains, or you're not going to spend enough money. And what's going to happen is your areas are going to flood. So this is a big issue that's come from urban areas as well. The large amount of stormwater runoff that's been generated. And here's just an example of what you might see, right? When you have large areas of impermeability, when water can't get through to the ground. Another point I want to make on why water-sensitive urban design is so important, especially in Australia, is because of our climate and our environment. A lot of you probably already know, Australia is known for being vulnerable to droughts. We're a drought-vulnerable country. With droughts, we also become vulnerable to bushfires, which we saw earlier last year. These droughts are a natural product of how our climate naturally doesn't have a lot of rainfall, or at least it has long periods of time without rainfall. But what people sometimes forget is that we're also vulnerable to floods, right? In Australia, we tend to have long periods of dryness, of no rainfall, but we also have short, intense periods of rainfall when they do come, right? These short, intense storms ultimately cause floods, which we commonly see in Australia, right? In Queensland, and more recently, earlier this year, in Sydney. So understanding that we're a country that's vulnerable to both sides of the spectrum in terms of the extreme events that we might experience, we really do have to start thinking more intelligently about how we're managing stormwater and how we're building our infrastructure, right? And these extreme events, what the science is telling us is that these extreme events are only become more frequent. Will only become more frequent with climate change. So looking to, as engineers and as designers and as planners, to start thinking about how we are going to build the infrastructure to make sure that we're going to be okay, not just when we don't have enough water, but also when we have too much water. That's going to be a big challenge, and that's something we're going to have to put a lot of brain power towards. But I'm going to hand off to Jack now. What I've told you is a lot of problems, and Jack's going to talk to you about what solutions might be available.
Yeah, so thank you, Jim. So in terms of how we might go about looking towards water-sensitive urban design and some solutions to achieve water-sensitive urban design, what we'd like to specifically focus on today at the CMAA is talking about permeable pavements. So firstly, what is a permeable pavement? Well, essentially, it's a pavement system that will allow water to infiltrate the surface and be stored and filtered through the underlying base course. So you can see here, I've switched to screen sharing to show you these little GIFs or videos of how you might see a permeable pavement work when it's exposed to water. So you can see here, we've got three main types of trafficable permeable pavements. So firstly, you've got your open graded or your porous asphalt, which you can sort of see in the top right there. And this is obviously where you've got that bitumen emulsion binder to create your sort of no fines porous asphalt system. Secondly, you've got a no fines or pervious concrete, which again works in a similar manner and will allow water to infiltrate through the actual concrete itself. And lastly, we have our permeable interlocking concrete pavers. So you can see these in the bottom right-hand system, and this is where you've got individual segmental pavers with small gaps or small or larger widened joints, which will again allow your rainfall or your water to infiltrate through the pavement surface system. So often when we think about water-sensitive urban design and how we might control water, often the conversation steers towards drainage systems, and it steers towards how big our pipes need to be and how large and frequent our drains need to be designed for. But what's often less considered is how the pavement surface itself might react. So today we invite you all to consider looking at the pavement surface itself as a potential solution for water-sensitive urban design, particularly at a local government area. So again, what is a permeable concrete interlocking segmental pavement? So essentially, this is going to be a pavement where, as I mentioned, you have small pre-cracked pavers or individual pavers, which will have either widened gaps, as you can see on the left, or actual joints on the right, which will allow water to pass through. Now, the main advantage of these systems in comparison to your no fines concrete and your permeable asphalt is that there's less risk of clogging with these types of pavements. So often the gaps and the void ratios in your no fines concrete and your porous asphalt are often a bit smaller than what you might see in your permeable interlocking concrete pavements. And so what this means is those systems are often more vulnerable to clogging over a longer period of time, which is why we see these permeable interlocking concrete pavements actually perform better on a long-term basis. And so that's why we recommend them here at the Concrete Masonry Association, particularly when we're talking about how we might design a permeable pavement to work in line with our water. So there's three types of concrete segmental pavers that we sort of represent and talk about here at the Concrete Masonry Association. So obviously you have your small format concrete pavers, you have your larger flag pavers, but then you have your permeable pavers, which again is the focus of today. And a few of the benefits of these pavers. So firstly, they're low maintenance and they're easily repaired. As I mentioned before, these permeable interlocking concrete pavers come pre-cracked. What I mean by that is they're obviously in smaller unit sizes than what you might see in your sort of concrete footpaths or bitumen road surfaces. And what this essentially means is that they're less likely to crack on a larger basis than what these other pavement systems will experience over their lifetime. And a very good example, or a very clear example that everyone here is probably familiar with, is looking at a concrete pavement around trees or looking at an older concrete pavement. And all too often, you're going to see these systems have large cracks and large uplifts. And obviously that becomes a huge issue from a maintenance perspective. Now, again, in the event that these high durable pavers do fail or do crack, it's super easy to replace them. It's a simple matter of lifting the individual paver up and simply replacing it with another paver. Boom, job's done. Again, these pavements are environmentally friendly. So I'll go into a little bit more of the benefits from a water resources perspective in a minute. But it's important to remember that these pavers can actually be recycled at the end of their lifespan. So a couple of examples of this, we can actually see that permeable pavers have been reused in between applications and in between purposes. A good example of this is the Sydney Olympic Park, where they actually reused old pavers, old concrete pavers to pave the area. But again, on top of that, if they can't be reused in another paving project, they can actually be broken down and used as aggregate for more pavers or more concrete. So from a reusability standpoint, they're also very beneficial. And again, this is going to save you time and money. So these pavers are also traffic calming. When we think about urban planning and urban design, we obviously want to make our spaces as safe as possible for both vehicles and pedestrians. Now, obviously, because of the pre-cracked nature of these pavers, they're going to create vibrations, and this will actually tend cars to slow down in these areas. And I will touch on this a little bit later. Less curing time as well, meaning that these pavers are ready to go. And as soon as they've been laid, they're ready to be trafficked. Now, from a local government standpoint and from a sort of construction standpoint, this is very advantageous because if you're conducting night works, for example, the minute you lay these pavers, they're ready to go the next morning. And finally, they're slip and skid resistant, meaning they can be used in a number of applications. So a lot of people think that concrete segmental pavers and pavements can only be used for pedestrian applications. But nowadays, we've got the technology and the resources to actually design these for streets, for pedestrian uses, but all the way up to airport hard stands and even container ports. So it kind of just goes to show the versatility of how you might use these pavers. But now looking towards specifically how a concrete interlocking permeable pavement system might work. So you can see here in this GIF, the way it works is that rainfall will hit the surface of the pavement and it will actively travel through either the widened joints or the porous pavers themselves. And it will actually travel through the permeable base course and the permeable bedding course. And it will actively run through the system to be stored underneath the pavers. So this water that's actually infiltrated our system can then either be allowed to go back into the underlying subgrade, or it can actively be pumped out and be reused for whatever reuse water application you might have. Now, as humans, we're quite arrogant when it comes to specifically urban design, and we like to control our environment and create controlled urban designs and urban situations. However, permeable pavements break the #1 rule of pavement design, which is to never let water penetrate the wearing surface of your pavement. And so the ideology here is to work with nature and work with rainfall and allow it to actively flow through the surface as it would in a non-urban situation. Now, we hear often concerns about water infiltrating the surface of your pavement. And this is often because engineers are concerned that when water gets underneath the pavement, it's going to create a pumping effect whereby a lot of the fines in the underlying base course are removed through the erosive force of water. However, if we think about how we can design these pavements, we can actually actively combat this situation. And so remembering that urban traffic is extremely destructive and that water can be a powerful eroding force, and that having a saturated pavement alters the material properties, we can actually try and think of some solutions to combat these to create our permeable pavement system. And what we end up with is having a no fines base course, which will allow water to filter through vertically through the base course whilst not having that erosive force that you would otherwise experience with an impervious surface. So by acknowledging these potential flaws and addressing them, we can actively have a pavement that will perform both structurally and hydrologically. So how do these work? So in terms of benefits and systems for permeable pavements, there's 3 main systems that you might want to consider with your hydrological design. So the first is runoff control. So as I mentioned before, permeable pavements are going to allow water and rainfall to infiltrate the surface. And you can see here through these 2 little GIFs how impervious pavements versus permeable pavements might work. So in an original situation with your typical impervious pavement, what would happen is that your rainfall would hit the surface, flow into a drain or a pit, and flow through the stormwater system. And essentially the inflow would be equal to the outflow immediately throughout the duration of that storm. What a permeable pavement aims to do is extend that hydrograph. So you can see here on the bottom left, the idea of having a permissible discharge in your system, or having certain infrastructure to allow a certain discharge. The aim of these permeable pavements is to store that water over a longer period of time so that your outflow doesn't go higher than your discharge. And essentially what this means in layman's terms is that you won't have flooding in your system because you will have the capacity to store and mitigate and remove this stormwater slowly. And again, you can sort of see how this works in this video as well. You can see rainfall slowly infiltrating the pavement surface and filling up in the base course, where it is slowly released either through a pipe or it's slowly released into the underlying subgrade. And what this means is that you won't get standing water on your pavement surface. So the photo that Jim showed before of the road being flooded from heavy rainfall, with a permeable pavement system, you won't get that. Now, the second main benefit for permeable pavements and a secondary system requirement that you might consider is water quality improvement. And now what do I mean by this? Obviously, when water hits our pavement surface, it's going to take with it all of the pollutants that are on that pavement surface. This is going to include things like your phosphates, nitrates, suspended solids. And so what a permeable pavement will do is it will actively filter out these pollutants. And it's quite simple in theory how it works. It's essentially gravity-fed mechanical filtration. So the water will enter the pavement through the gaps that I mentioned before. And as it sort of bounces around and hits the aggregate within the bedding course and the base course, those pollutants will actually, stick to those aggregates and get filtered out as the rainfall infiltrates downwards. And so what you can actually get is a stone reservoir mechanical filtration system, whereby your phosphates, your nitrates, and your suspended solids will actually be stored in the bedding course and the base course, and clean water will be released at the bottom of your pavement system. Now, a concern we get here is that what happens if your base course or your bedding course gets polluted over time? And what it's important to consider is that a lot of these compounds entering the system are organic compounds. So what will actually happen here as these organic compounds get filtered out is that they will be broken down by bacteria. So you shouldn't get the issue of having to have bacteria filtering out these pollutants further down in your water treatment system. It can happen right here and now in your permeable pavement system. Now, lastly, we've got water harvesting as something you might want to consider with regard to water-sensitive urban design and the design of permeable pavements. Now, as I mentioned before, water can be stored in the base course of these pavements. Seems pretty simple. So what you can actually do is design your base course to be large enough in volume to actually store a certain amount of water, depending on your climate zone and depending on how much rainfall you receive, and also depending on how much rainfall you obviously want to reuse for later applications. So what will obviously happen here is that you will have rainfall enter your permeable pavement system, and it'll be stored in your base course. And you can actually have a pipe and a pump to actually pipe out and pump out this water, which you can then store for later reuse. And a great example of this is having a permeable pavement in a car park for a sports oval, because you can obviously capture all of the rainfall that hits the surface of this car park and use this water to actually water the grounds of the oval. And from a local government standpoint, this is great because it means that you don't have to then pay for water to actually irrigate these areas. So to sort of sum up some of the main systems and some of the main applications of permeable pavement systems, obviously from water-sensitive urban design and sustainability standpoint, we can look at flood control. So obviously these pavers are going to mitigate the risk of flooding as they will store water in the base course. Additionally, the stored water in the base course can be reused, meaning that it's not going to waste. And you're also improving your water quality as well, meaning that pollutants aren't going to make its way into the stormwater system in the first place. Now, again, if we're talking about economic benefits as well, you don't actually have to put in drainage infrastructure into a lot of your permeable pavement systems, particularly if you're going to let the water infiltrate slowly into the underlying base course. You don't even need a pipe, you don't even need a pump for this water, which actually minimizes the need to construct, design, drains and pipes. Again, property protection, minimizing the risk of flood, meaning that properties are often safer, and you're just going to be maximizing your land use and maximizing how sustainable your area is going to be with these permeable pavements. So in short, kind of combining all of these benefits, it's realistically a multifunctional, holistic pavement solution that you're going to be able to employ, particularly to reach those targets for water-sensitive urban design. So I think I might hand over to Jim now, and he might go through some of the benefits of using our DesignPave and Permeable program. So I think the GIFs, we no longer need the GIFs, so we're going to switch back to regular slides on Demio now. I'll let you take it from here, Jim.
Yeah, let me just fast forward. So if you're wondering how exactly would you design a permeable pavement, well, we've got you covered at the CMAA, because we here at the CMAA, in partnership with the University of South Australia, have actually developed a software program to help you do exactly this. And this is the DesignPave and Permeable programs that we have. DesignPave being the structural part of the program, and Permeable being the hydrological side of the program. So DesignPave and Permeable is quite unique in that it's the only program in the world for permeable interlocking pavers. Just gonna give you a quick rundown as to how the program works exactly. The point of today is not to overburden you with a lot of technical information, but it's to give you a high-level understanding of what exactly is permeable paving and why water-sensitive urban design is important. So to put it in real simple terms as to how the program works, we're going to use the bucket analogy. And that's all a permeable pavement is. It's just a fancy bucket with a hole at the bottom, right? So when a big storm comes through, what happens is instead of instantaneously, having your stormwater system being subjected to a high amount of water, what you have is a temporary water storage solution to temporarily hold that water and over a longer period of time, release that water at a constant flow that you as the designer have specified. Your pavement can be modified in all sorts of ways through changing your paver type, through changing your base course material, through changing, what subgrade you're actually building on. And you can change and customize all these inputs in the program. And that's essentially changing how big your bucket is, right? How deep your bucket is, or how big the hole is at the bottom of your bucket. What the program then does after you've, specified what your bucket is like, is it then uses data from the Bureau of Meteorology and applies different rainfall patterns depending on the location that you've put in. It also takes into account the different temporal patterns as well. And what I mean by that is that, rainfall doesn't come all in one go. It's not constant, right? And we all know this. For a 30-minute storm, for example, the majority of your rainfall volume might come in the first 10 minutes. Alternatively, it might come in the last 10 minutes, right? So all these different patterns, Permeable accounts for, and how it does that is it uses data from, ARR. Lastly, after applying everything that I've said, it calculates whether your bucket, your pavement, will overflow or not. If it overflows, the program makes a design suggestion. It might suggest that you make your bucket a little bit bigger. It might suggest that you make your base course a little bit deeper. And that's how the program works. And by the way, the program's free to use, free to download. So if you haven't already, I highly encourage you to check it out and have a play around with it. Runoff analysis is only one section of the program. There's also the water quality and water harvesting sections of the program as well. And we've got some screenshots there, as well as the DesignPave component, which I mentioned earlier. And the DesignPave component, again, is the structural side of things. analyzing your pavement and seeing how many axles or how many vehicles your pavement can actually withstand. And again, Permeable and DesignPave is quite unique in being the only structural and hydrological design software in the world for interlocking concrete pavements. And it's also unique that it's specific to the Australian climate, right? And the aim of why we developed this program, this software, is really to make designing pavements easier for you. Designing interlocking pavements and permeable pavements by hand is quite a long process. With DesignPave and Permeable, you can achieve that easily with a click of a button, right? And here are some projects that were designed with Permeable. And you can see they can be used for both big and small projects, whether it's your own residential driveway or if it's a car parking area for a big university institution. I'm just going to quickly run through policies and market development, having a look at where we are currently in the world and how we compare with some other countries when we're talking about permeable paving. So permeable interlocking concrete paving actually first emerged in the 80s, with Germany being the first adopter of this technology. During that early time, a bunch of other countries adopted the technology as well. Countries across Europe, South Africa, USA, and Australia as well. Australia was actually one of the early adopters of the technology. We've since fallen behind the rest of the world a little bit, and I'll get into why that has happened in the next couple slides. Just to keep in mind, water-sensitive urban design, when you might be looking for technical resources, you might notice that everything's applicable to Australia. All the resources are from Australia. That's because water-sensitive urban design is just the name that we've given it here in Australia. It has different names in other countries as well. In the UK, it's called sustainable drainage systems, for example. So just something to keep in mind. In Germany, Germany's arguably the most advanced country in terms of its adoption and support for permeable interlocking concrete pavers. One reason is because it was an early adopter. Another reason is because the government has really had a proactive role in encouraging the replacing of impermeable pavements with permeable pavements, right? And how they've done this is actually quite smart. If you are living in Germany, if you own property in Germany, what you'd have to usually do is you'd have to pay a stormwater fee, right, to help upkeep any stormwater assets that your government would own. In Germany, this stormwater fee is variable depending on the area of permeable paving that you would have. If you have a large impermeable surface, that would obviously generate a lot more surface runoff than a permeable surface, sorry. And the stormwater fee takes that into account. So if you have more permeable surfaces, then you have to pay a lower fee. And that's been a key part in driving down the impermeable surfaces in Germany and driving down that runoff as well, as we see at the bottom right graph. And again, Germany's quite good in this respect, and 2/3 of all engineered pavements in Germany are actually permeable. Moving on to the Netherlands, not quite as there as Germany, but still fairly good, with 1/3 of all engineered pavements being permeable. The thing about Netherlands is when you think about how they are a flood vulnerable country with a lot of their land area under sea level, what has happened is that the government has actually invested a lot of money into flood risk mitigation, right? So if we were to learn from them, and if we were to look at, what they're kind of doing, seeing how they've adopted permeable pavements, that really is a lesson to be learned. Moving on to the UK, one good thing about the UK is they have their own equivalent of CMAA, and that's the Interpave Association, right? So they're essentially the British version of us. They're really good because they've worked really hard to develop the technical resources to help people design permeable pavements accurately. A lot of the times, people might not necessarily know how to design it and construct them properly, and providing the guidance for that is really key. Another key part is that the government policy guidelines has actually encouraged permeable paving a lot as well. If you were a developer in the UK and you wanted to build a car park, for example, outside a shopping mall, if you wanted to use permeable paving, no problem. You can go right on ahead. If you wanted to use impermeable paving, however, then you would have to justify and provide reasoning for why you're using impermeable paving. And that, again, has really encouraged the adoption of permeable surfaces. Similarly, the United States also has an American association, the ICPI, which is just the American version of CMAA. That has been a key part as well in providing and educating the industry on how to design permeable pavements. They've also had a lot of really good government policies and agencies in pushing towards more sustainable stormwater management. What you might have noticed with the countries I've just talked about is that a lot of these countries have a top-down approach, right? Australia is a little bit different in that we have more of a bottom-up approach, where it's really up to the designer to convince people to use permeable paving. And this is one of the bigger reasons why, even though we were an early adopter of the technology, why we've fallen behind since then. In Australia, generally speaking, though it does vary state from state, generally speaking, it's your local governments who manage stormwater and who own those stormwater assets. So at the end of the day, it's really up to the local governments it's up to their discretion to, see how they want to manage that stormwater, whether it's through drains or whether it's through permeable paving. We've seen a few councils who are really proactive and have done really well and are really enthusiastic in adopting permeable paving projects, a few in South Australia, for example. And more locally for me, actually, in New South Wales, in the locality that I live in Ku-ring-gai, the council actually offers rebates depending on what type of water harvesting systems you might have. And permeable paving does fall under that rebate program. But for a lot of councils, permeable paving doesn't seem to be on the radar. Part of that might be because they might not know how to design permeable paving. It might be a little bit scary, but that's what we're here for, right? As the industry association for concrete pavers, we really want to help you, and we really want to work hard to educate the industry on how to correctly design permeable pavements and make sure that they do last a long time. Another reason why Australia has fallen behind is because as an early adopter, early in the 90s, at the time we didn't have a really good understanding of how to design and construct permeable pavements. Since then, our understandings have grown a lot. And again, here at the CMAA, we've developed a lot of technical manuals, and we've developed the DesignPave and Permeable softwares to help designing permeable pavements more easy and more accessible to people. And we really hope you are proactive and do check out these resources because we want your assets to work, and we want them to last a long time. Just finishing off before I hand off to Jack, I just want to finish off on probably one of the most famous permeable paving projects in Australia, and that's the Sydney Olympic Park. And what a coincidence with the Olympics happening now. Sydney Olympic Park, built over 20 years ago, has large areas that are permeable, right? And it was really quite innovative for its time. The fact that it's still standing today and the fact that it's still looking as sharp as ever is a testament to how durable and how versatile that permeable interlocking concrete pavements are. And the notion that permeable pavements are weaker or they might not be as versatile as we might think is just not true, right? If you've ever visited Sydney Olympic Park, what you might also notice is that there's actually a lack of drainage infrastructure. And that again goes back to how permeable paving can reduce your need for pits and pumps. A lot of especially if you're in local government, pits and pipes are incredibly expensive to build and to install. And more importantly, when you inevitably need to have those expansions to your stormwater systems, they're incredibly expensive to expand for growing populations as well. So having a permeable surface to, number one, reduce your surface runoff, and number two, reduce your need for pits and pipes is really a no-brainer. And because of how it reduces the need for pits and pipes, permeable paving, if you look at the whole life cycle, does actually tend to be cheaper in the long term. Now I might pass off to this last section, pass off to Jack and talk about some further applications of permeable paving.
Yeah, thanks, Jim. Just before I get into this section, it's great to see we've had some really great discourse in the chat here. I probably should mention Keanu, one of our pavement engineers here, is in the chat answering some of your questions, and there's some great questions in there. So yeah, David and Martin both asked about pollutant saturation and whether this can be an issue with clogging in pavers. So as Keanu's mentioned, pollutant saturation does generally occur over a 10-year period and is about 10% of the effectiveness. The other thing that's worth considering as well with regard to which system you might want to use and which one is more consistent or clogs less frequently is the idea of maintenance and sweeping. So at the CMAA, we do recommend sweeping every 6 to 12 months of these pavements, and that can exponentially expand the lifetime of these pavement systems. The other thing that's worth considering as well, just as Jim's talked about DesignPave, particularly Permpave, it does take these factors into account with the infiltration values of the specific types of permeable pavers as well. So it actually uses more conservative values for these pavers as well, which takes into account the potential clogging that can and naturally will occur over an extended period of time. However, keeping in mind these pavements, the reduction of clogging can be combated with this regular sweeping. And you can see this obviously through the Sydney Olympic Park example that Jim's just taken us through really quickly. But yeah, it's great to see Keanu and Martin, a little bit of research there as well. So good for knowledge sharing. The other thing Sean mentioned, that you might need a pipe system to cater for larger storm events, and the idea of water infiltrating a reactive subgrade. So again, the benefit of DesignPave and Permpave is that you can actually use IDF curves through AR&R for your specific local government area or for your specific region. So you can actually look into the different, annual exceedance probabilities for your actual rainfall design storm, and you can actually design your base course appropriately to ensure that in those larger storms, it's still going to perform. And obviously, again, if you do have those reactive soils, then you can take into account the sort of drainage infrastructure. Permpave will help you with the sort of radius and diameter of pipe you might want to put at the bottom of your design base course thickness. So again, to sort of shamelessly plug DesignPave and Permeable, it actually does address these factors, which are really great concerns, like common concerns. And obviously, as Jim mentioned, it's specific to the Australian climate and the Australian weather patterns. So it's going to actively help to combat those common questions. I will quickly sort of zoom through this end section, which is going to flow into some future episodes of this webinar. And then we'll probably get back to some of the questions further down in the chat as well. But I think Keanu is also there as well. So again, feel free to keep asking those questions and we'll get to them in a second. So just in terms of your further applications, obviously one thing that's worth considering as well with regard to urban planning in particular is the idea of solar reflectance index and the urban heat island effect. So obviously, you can see in this picture, this does a great job of sort of comparing how a rural and an urban area might perform in a warm situation with regard to storing heat energy through the different solar reflective index in materials. So obviously what you'll get in a rural area is you'll have these lighter natural colored surfaces, you know, your plants, grass, trees, that will not actually absorb as much heat energy as you would see in darker spaces, particularly sort of your asphalts and concretes and steels. And so what obviously this means is that your surfaces in these rural areas will not absorb this heat energy and will remain, the surrounding environment will retain its comfortable temperature. Additionally, it's worth considering the effect of rainwater infiltration in pervious surfaces and how this might cool the surrounding environment. So when rainwater or water actually infiltrates the surface, it is generally stored below. And if it actually evaporates in warmer temperatures, it will actually cool the surrounding environment. And this is a process known as wicking. So obviously in urban areas without these impervious surfaces, you're actually not going to get this wicking effect to the same degree, meaning that you're not going to get this evaporating water cooling the area in the same way. And it's exactly how evaporative air conditioners and coolers work. It's just Mother Nature's natural process. So what this sort of comes into play when we're thinking about water-sensitive urban design is that these permeable pavement systems will actively allow for that wicking effect to take place. But on top of that, they also come in a larger variety of colors. Obviously, with asphalt, you're often restricted to that darker, almost black color, which again is going to absorb a lot more of that heat energy. However, with pervious concretes, but specifically PICP, you've got a range of colors which will actively help you combat this urban heat island effect. And as you can see through that graphic, it can be like 3 to 10 degrees. So it's a significant amount that we can actively try and reduce just through some, you know, simple urban planning schemes. And again, I think this slide illustrates that point as well, and it illustrates the idea of the wicking effect as well. You can see the sort of heat image on the left. I believe this is a city, I believe this is Melbourne. Correct me if I'm wrong, Jim, but I believe this is Melbourne, but it shows the darker impervious surfaces there, over 60 degrees in temperature. And again, underneath those trees, it's going to be almost half that temperature. So if we think about how permeable pavers might work, actively they're going to reduce the heat energy that's stored. And you can see the heat fluxes of the different materials compared on the right-hand side here. So obviously during the day, PICPs have almost a third of the daytime sensible heat flux of those of porous asphalt. And we'll go into this more in future episodes of the webinar as well. Again, as I mentioned at the start of this webinar, the idea of traffic calming also comes into play. And this is relatively specific to your concrete interlocking pavers. Obviously, because they are pre-cracked, it's going to sort of create additional friction and additional vibration through wheels driving alongside and on top of these pavements. And so what that's actually going to do is encourage drivers to slow down, which makes these pavers really, really great for areas where you want low-speed traffic. Obviously, this is going to include your car parks and school zones, but more and more, we're also seeing shared zones pop up in urban planning. So in terms of where you might consider permeable concrete interlocking pavers, if you're in an area where you are, wanting these lower speeds with your traffic, then definitely this is worth looking at as well. And again, we'll get into this in further detail in future episodes. And another massive issue, probably one of the largest issues for engineers in local council, is the idea of tree root uplift. So obviously, as tree roots grow, oftentimes they're actually going to grow towards the surface to chase additional water and nutrients. And so the current issue that we see is that in impervious surfaces, the water isn't allowed to infiltrate below the pavement surface, meaning that the underlying subgrade is not getting the required moisture and nutrients that a tree will need to grow. So what ends up happening is obviously the tree goes in search of this moisture and nutrients. Sort of makes sense. They're chasing their nutrients and their food. And what you see here is you see these tree roots growing upwards and eventually cracking your pavement surface. Now, what a permeable pavement will do is it will actively allow this moisture and these nutrients to sort of go down into the underlying base course and then eventually subgrade. And this is going to encourage trees to sort of put out those initial fibrous roots deeper into the root structure, which will then turn into sort of your more heavier woody roots that you'll see, particularly with your larger trees as well. So you can see a really great example. Obviously, this is with juvenile trees, but you can see how using permeable pavements will encourage these tree roots to grow deeper and deeper as the sort of life cycle of the pavement goes on. And once again, we plan on doing a full episode talking specifically about tree root uplift. And I think Jim's just posted a poll in here as well with regards to, what benefits interest you as an engineer most. And this is obviously what we're going to look towards for future episodes of this webinar. All right, I think, Jim, if you want to take it away from here.
In conclusion, obviously we see that water-sensitive urban design really is needed in Australia, not just because of our climate diversity and how we're prone to different sort of extreme events, but also because of the issue of population growth and urbanization. And we really need to start thinking intelligently about how we're going to develop the infrastructure to support these growing populations. Permeable paving is a really fantastic part of how you might be able to achieve water-sensitive urban design. It has a lot of added benefits, such as stormwater management, as well as the ones that Jack talked about earlier, urban heat island effect, tree root uplift, and water quality improvement. But at the end of the day, what we'd like to see most as an industry association is to see local governments and consultants really start to think more proactively about permeable paving projects. And look, as an industry association, we're here to help. If you're curious or if you're unsure about a particular design, we're happy to set up a Teams meeting with you. We have a lot of really fantastic team members here. And we also have access to the industry, right? We have access to some of the brightest people in the industry. So I really encourage you to get in touch with us. Again, as the industry association, we want to engage with you guys. We want to engage with the industry. So get in touch. We're happy to provide any technical assistance wherever possible. And thank you for coming, really. Again, we have a range of different programs, manuals, and softwares that we highly encourage you to check out. And we also are holding our next webinar episode in September, 29th of September. So I encourage you guys to come along, and I hope to see all of you there.
Yes, I think we'll take this opportunity now to have a look through some of the questions in the chat, and we'll try and address some of these for you all. So obviously feel free to stay and listen to some of these answers. Obviously, I know that everyone here is very busy, so feel free to go about your own way. So I think I'm just scrolling back up to the chat to see which ones we've addressed. It's been great to see, though, that everyone's had some really great questions. So yeah, there was some concerns, I believe, from Dale in regards to having infiltration close to buildings below permeable pavements. So I believe, yes, there are some guidance available for that. I believe in Australia, there's not a lot of information for this. However, I believe the British standards do address this. So what we'll try and do is we'll dig up this document and circulate, but we'll also aim to put this information into the next episode as well. There's also been a lot of questions on trees, specifically what type of trees to plant, whether you can use juvenile and mature trees with permeable pavements. So the shorter answer to this is that juvenile trees obviously work best, and you want trees that are going to have roots that will encourage that sort of fibrous and woody growth downwards through your permeable pavement. However, there are strategies to actively use permeable pavements around mature trees in a correct manner so that you're not going to get that extreme tree root uplift that you'll often see, particularly with your, for example, concrete footpaths. So what we'll do to address all of these questions, because it seems like there's a really great amount of interest for this, is we're probably going to focus on tree root uplift in the next episode of this webinar. So we're doing these bi-monthly. So the next one, as the screen says, will be at the end of September. However, that being said, we will try and distribute any literature as well in the meantime, just in case you're after a specific answer right now. But keep in mind that you can, again, use these pavements for both juvenile and mature trees, but we will touch upon that in the next episode. All right, where are we up to next? Thank you, everyone, as well, that's saying thank you in the chat. Jude, yep. Yep, so someone asked whether the Sydney Olympic Park was swept to minimise clogging. Yeah, I believe every 6 months is what the local council does. I think, yeah, it's definitely quite frequent. I know personally I've actually seen sweepers there when I've actually been to Sydney Olympic Park in the past. I was lucky enough to sort of see them doing the maintenance. But again, just to sort of solidify what we've said in regards to pollutant control. Obviously, natural clogging can and likely will occur to a degree. It's just sort of the way that water infiltration works into these permeable pavements, regardless of whether it's an asphalt, a pervious concrete, or the actual permeable pavers. It's just a matter of proper maintenance. But again, using Permpave as a program will actively take this natural effect of clogging into consideration. And it uses those more conservative values to ensure that the pavement is actually going to last for a long time. Dale also asked, should councils ask for a Permpave design report when receiving planning applications? We recommend it. Permpave is, like, as we said, it's great specifically for Australia. So it isn't actually compatible with music software, as Keanu has pointed out in the chat. However, we find that it does work quite well to address most of the concerns for music, particularly in regards to water quality improvement. And it has a similar model to what music employs. So you often can use this to actually design your permeable pavement for both runoff control, water storage, but most importantly, in this specific regard, water quality improvement. Yep, so Dale said, yep, would love to see more about permeable pavers for passive irrigation of trees. Yep, so I think, again, in next episode when we're talking about tree root uplift, I think we'll cover that as well. Martin, the base course is equally as important as the wearing course, the top layer, and the sub-base forms 50% of a correctly constructed permeable pavement system. Yeah, that is correct. The base course is incredibly important, and that's often what DesignPave aims to do from a structural basis. So Permpave is going to address your sort of hydrological performance of your pavement. It's going to design your base course thickness with regards to your water runoff control, your storage, and your mechanical filtration for water quality improvement, depending on which one of the three, or whether you want all three of those properties to perform within your pavement. But then DesignPave will actually go back and confirm that design from a structural basis, and it will actually tell you, for your estimated amount of traffic using this pavement, whether the base course thickness is going to be adequate enough. And again, you can then fiddle around with the different settings in DesignPave to incorporate a sub base into the system. And obviously, depending on what the MPA of your sub base is, and depending on your CBR of your underlying subgrade, DesignPave will sort of show you what's going to be appropriate for both a sub base as well as a base course thickness as well. So that's the benefit of using this program, specifically when you've got these reactive soils that may need subgrade improvement or stabilization. Are there case studies of life cycle costs of permeable pavers being less than a conventional approach? So I'm actually not 100% sure off the top of my head. However, Jim may know.
Yeah, there are. I think it was undertaken by the British version of us, the UK version of CMAA, and we can find that for you for sure. And again, that goes back to how permeable pavements need less pits and pipes. That's the big reason behind it, and also more durable, right?
Becky also just asked, she's only just managed to arrive, will this be available to rewatch? Yes, Becky, we will distribute the recording for this demo presentation to all the attendees today. So fear not, you will be able to come back to this. And Dale has asked, would love to see a presentation on using PermPave. Yes, definitely. This is something that we do want to touch upon. We'd like to go through an application of both PermPave as well as DesignPave. So yes, Dale, this is something that you can expect from us to go through in future episodes. But again, to anyone that's here as well at the moment, if there's any run-throughs that you would actually like to see with DesignPave or PermPave, particularly if your team is starting to get familiar with the software or use the software for an upcoming project, and if you're struggling with any of the inputs, or you're unsure of what's the correct rationale, again, that's where I would encourage you to get in contact with us, and feel free to ask us to do a run through for you and your team. We're more than happy to schedule a time to go through it and incorporate it specifically to what you need to ensure that your designs are going to be concurrent with your parameters. I'm just double checking that I haven't missed any up. It's great to see. There's a lot of chat on the right hand side here. So Jeff, tree roots tend to travel along the path of least resistance rather than looking for water. So generally, root uplift is caused by compaction of soils around the tree root zone, caused by traffic and installation of compacted subgrades. And tree cells can alleviate this. Yes, so we are seeing that tree cells are being more and more used. I believe we did get an inquiry about this a couple of weeks ago, Jim, is that correct?
Yeah. The thing about tree cells is it's really not necessary. When you use a permeable pavement, and tree cells, they can't handle as much loads as structurally designed permeable pavement either. But it's, from my understanding, tree cells are more or less redundant. If you have your base course doing the work for you, there's really no need. Tree cells are really beneficial if you want a really large amount of water storage under your pavement.
Yeah, and just on top of that as well, as Keanu's pointed out as well, the subgrade compaction for permeable pavements as well as the base course treatment as well is different to typical pavements. And obviously, because you want the void ratio in your base course, the compaction levels are different to those of typical pavements, which does mean that your compaction is often less, meaning that the path of least resistance, meaning that trees are still going to sort of encourage that growth downwards. Nadika, can we expect predicted results with a clogging problem, or what would be the efficiency of such a system? So in terms of clogging, as I've mentioned before, over 10 years, your system may tend to slightly clog with some of these pollutants. However, again, the design of PermPave takes into account conservative infiltration values for the pavers themselves. And this is from research at the University of South Australia. So the system will still retain its efficiency as it gets older as well. I remember Professor Simon Beecham. He is one of the leading people that developed the DesignPave and PermPave software. He mentioned that in one scenario in his lifetime of designing pavements as an engineer, they have needed to uplift the pavers and replace the bedding course. However, that was in an extreme scenario and the pavement wasn't designed up to specifications for its areas. So according to him, he is yet to see a permeable pavement system that has been clogged to the degree where it won't perform adequately from the design process, years in the past. All right.
Yeah, so Jim, I think you had a question about geotextiles between the bedding and the base course. That's a really good pickup. One of the newer understandings that we've found out is that you're absolutely right. Don't use geotextiles between your bedding and your base course. Previously, it has been used to prevent that migration of the smaller bedding sand into the base course. But because of how the ratios between each of the aggregates are sufficient enough that migration is really not needed. It doesn't really happen. What does happen when you do put a geotextile down is you create a lot of slipping planes, and that's obviously not good for your pavers, and that can cause some of the pavers to move around. So you're absolutely right.
Yep. So Renata also asked that commented that contractors have raised concerns with achieving compaction with these low fines aggregates that you might use in a permeable pavement. So as Keanu pointed out, contractors do love the use of bedding sand. However, in terms of the compaction of these, we can reach out. We've got some companies with our members, and I think Keanu's mentioned that he will reach out to them as well. But yeah, generally it's been successful with regard to the actual compaction of these low fines aggregates as well. It's sort of a mixture between achieving obviously the strength of your base course versus the void ratio and water storage of your base course as well. And this is obviously, again, what sort of DesignPave and PermPave will aim to address. Because again, more compaction is going to mean higher strength, but it's going to mean lower void ratio, which means that your water storage capacity and capabilities of your pavement system will then decrease. So it's sort of a balancing act. Macias, can you please send the program for the next presentation? Yes, so when we send out the recording for this presentation, we'll send out the program for the next presentation. And obviously everyone here that attended will get the email registration link as well for next episode. So keep an eye out. And again, obviously, if you don't see the email or if it's somehow missed, you obviously get in contact with us and we'll make sure that you have all the information you need for the next episode.
Yeah, or follow us on social media.
Yes.
Find out.
Yes, follow us on LinkedIn in particular, I think, for more information about our webinars, because there's always more information being posted on there, whether it's on pavements, whether it's on concrete blocks. But yeah, you'll definitely hear something about the next episode on LinkedIn at the very least. So Jeff asks, how do you prevent soils for the tree growth area being compacted during the installation of the subgrade? The cell system would surely work in unison with the subgrade and support the installation of the permeable pavement over the root zone. Yeah, so again, Jeff, we're going to cover a little bit more on how we might use permeable pavements with regards to trees and combating tree root uplift in the next episode. So I think we're going to cover a lot of that there because there were quite a few questions earlier in regards to tree root uplift, unless Keanu may have an answer coming your way in a second as well. But yeah, I think he said he's going to dig out some of the specifics for you. Yeah, I don't actually have the information on hand right at this point in time, but obviously happy to do the digging for you. And Eduardo, the output from DesignPave gives layer thicknesses and material moduluses for the base course and sub-base layers. Do you have any guidance on the material modulus values for different permeable base and sub-base mixes? Yep, so we do actually have some guidance for the modulus values and what you might want to select depending on what you're using. I know that Ostroads, I believe, has some uniform or like recommended values, I should say. But I think Keanu is again going to send that out your way. So I think we might package it up as well so that everyone has this relevant research as well. It's also worth mentioning as well to anyone that's still here, obviously with DesignPave and Permpave, with that program as well, if you're using it and you are unsure as to any of the inputs or you are unsure as to what you might need to input or might need to change for your specific design or for your specific pavement, whether it's a permeable pavement or a concrete segmental pavement, there is also the help option on the DesignPave program and the Permpave program. And it actually opens up a PDF which sort of shows you the rationale behind the program and sort of digs out the relevant resources that are referenced to create the program. And it's really great for if you're just like not quite sure what a specific parameter means or what a specific parameter might need to be changed to or how it might affect the design. Often opening up this page will give you a little bit more information and help you out with, how to adjust those values so that it's concurrent with your specific scenario. Yeah, so Keanu's just said answers will be provided to everyone. No one will be left out. Great to hear. And yeah, thank you for being here as well today, Keanu. You've been doing a great job in the chat. Yes, I think we've hit the bottom of the chat now. Are there any questions that we've missed? Does anyone have any questions at the end here?
I think we're good. We might wait maybe 1 more minute in case any last questions come through. But yeah. Thank you everybody for staying till the end, and it's a real pleasure seeing you all here.
Yeah. No, it's been great, and it's been great discussions in the chat as well. So thank you everyone for contributing to the chat as well, and asking some great questions. It's great to see the interest. Specifically new research, new questions, and yeah, we hope to address any that we haven't specifically addressed today. Definitely, we hope to address those at the very least in the next episode as well. And yeah, once again, as I've mentioned probably 2 or 3 times already now, but if you do have any specific DesignPave or Permpave questions, or if you're doing a paving project and you're not quite sure what the best way to do it is, or just general design guidance as well, whether it's today, whether it's in a week's time, a month's time, just send us an email. Obviously, our emails are on the screen at the moment. And obviously on our website, on the CMAA, we've got an email and a contact number there as well. So any questions, big or small, we're happy to attack them for you and give you the design and construction and maintenance advice that you need.
All right, we might close it off then. Again, thank you everybody, and hope to see you in the next one.
Thanks everybody.